Hello students, today's topic is Leibnitz test, which is used to test the convergence of an alternating series. Now let us see what is alternating series. Alternating series. A series whose terms are alternatively positive and negative is called an alternating series. A series whose terms are alternatively positive and negative is called an alternating series. Okay, this is in the form of u1 minus u2 plus u3 minus u4 plus and so on. Okay, and each un greater than 0. Okay, u1 minus u2 plus u3 minus u4 plus and so on, alternatively positive and negative. This is called an alternating series and it is denoted by sigma minus 1 whole power n minus 1 un. N is 1 to infinity. Okay. Now Leibniz test. If un is a sequence of positive terms such that u1 greater than or equal to u2 greater than or equal to u3 greater than or equal to and so on, un greater than or equal to un plus 1 and so on. Okay, that means uns are decreasing terms and limit un as n tends to infinity is 0, then the alternating series sigma minus 1 whole power n minus 1 un, n is 1 to infinity, is convergent. Okay, uns are decreasing terms and limit un equal to 0, then the alternating series is convergent. Okay, this is Leibniz test. Now problems on Leibniz test. First one, test the convergence of sigma minus 1 whole power n all by square root of n into n plus 1 into n plus 2. Okay, given series is sigma minus 1 whole power n all by square root of n into n plus 1 into n plus 2. This is an alternating series. Here un is equal to 1 by square root of n into n plus 1 into n plus 2. Okay, we know that n into n plus 1 into n plus 2 less than n plus 1 into n plus 2 into n plus 3 for all n. Okay, therefore square root of n into n plus 1 into n plus 2 is less than square root of n plus 1 into n plus 2 into n plus 3. Okay, and therefore 1 by square root of n into n plus 1 into n plus 2 is greater than 1 by square root of n plus 1 into n plus 2 into n plus 3. Okay, but this is un and this is un plus 1. Therefore, un greater than un plus 1 for all n. Okay, and limit n tends to infinity, un is equal to limit n tends to infinity 1 by square root of n into n plus 1 into n plus 2. But as n tends to infinity, this tends to infinity. Okay, hence 1 by infinity is 0. Limit n tends to infinity, un is 0. Okay, already you have un greater than un plus 1 and limit un is 0. Hence by Leibnitz test, the alternating series sigma minus 1 whole power n into un is convergent. Okay, that is, the given series is convergent. Next problem, test the convergence of the series sigma n is 1 to infinity cos n phi by n square plus 1. Okay, solution. Given series is sigma n is 1 to infinity cos n phi by n square plus 1. And you know that cos n phi is minus 1 whole power n. Let's say this is sigma n is 1 to infinity minus 1 whole power n by n square plus 1. This is an alternating series. This is an alternating series. Here un is equal to, un is 1 by n square plus 1. Okay, for all n. Okay, so you know that n square plus 1 less than n plus 1 whole square plus 1. That implies 1 by n square plus 1 is greater than 1 by n plus 1 whole square plus 1. But 1 by n square plus 1 is un and this is un plus 1. Therefore, un greater than un plus 1 for all n. And limit n tends to infinity un, that is limit n tends to infinity 1 by n square plus 1. Okay, as n tends to infinity, n square plus 1 tends to infinity, this becomes 0. Limit n tends to infinity, un is 0. Already we have un greater than un plus 1 for all n. Okay, hence by Leibniz test, given series is convergent. Okay. Next problem. Test the convergence of the series x by 1 plus x minus x square by 1 plus x square plus x cube by 1 plus x cube minus and so on, where 0 less than x less than 1. So clearly this is an alternating series since the terms are alternatively positive and negative. Okay, this is an alternating series. Here un is equal to x power n by 1 plus x power n. Since x greater than 0, each un greater than 0. Okay. Now consider un minus un plus 1 is equal to, what is un here? X power n by 1 plus x power n, minus un plus 1 is x power n plus 1 by 1 plus x power n plus 1. Okay. We're taking LCM, this becomes x power n into 1 plus x power n plus 1 minus x power n plus 1 into 1 plus x power n, all by 1 plus x power n into 1 plus x power n plus 1. This is equal to x power n, this is x power n into x power n plus 1 minus x power n plus 1 into x power n cancel. This is x power n minus x power n plus 1 by 1 plus x power n into 1 plus x power n plus 1. Okay, this is equal to, take x power n common, x power n into 1 minus x all by 1 plus x power n into 1 plus x power n plus 1. Okay, already here x greater than 0, that's why this is greater than 0, x power n greater than 0. Since x less than 1, 1 minus x greater than 0, that means this is greater than 0. un minus un plus 1 is greater than 0. Therefore, un greater than un plus 1 for all n. Now, limit n tends to infinity, un, that is limit n tends to infinity, that un is x power n by 1 plus x power n. Okay, this is equal to 0 by 1 plus 0. Since as n tends to infinity, x power n tends to 0. Since for 0 less than x less than 1, we have limit x power n as n tends to infinity is 0. Since 0 less than x less than 1. Okay. Now limit n tends to infinity un is 0. Already we have un greater than un plus 1 for all n. Hence by Leibnitz test, given series is convergent. Given series is convergent. Okay. Next problem. Test the convergence of the series 1 by 1 into 3 into 5 minus 1 by 3 into 5 into 7 plus 1 by 5 into 7 into 9 minus 1 by 7 into 9 into 11 plus and so on. Okay, this is an alternating series since the terms are alternatively positive and negative. An alternating series. Okay, here un is equal to 1 by 2n minus 1 into 2n plus 1 into 2n plus 3. Okay, and here each un greater than 0. Okay, and clearly we have un greater than un plus 1 for all n. Okay, now limit n tends to infinity, un is equal to limit n tends to infinity. What is un here? 1 by 2n minus 1 into 2n plus 1 into 2n plus 3. Okay, as n tends to infinity, this tends to infinity, and 1 by infinity is 0. Okay, limit n tends to infinity, un is 0. Already we have un greater than un plus 1 for all n. Hence by Leibniz test, by Leibnitz test, given series is convergent. Okay. Okay students, thank you so much for watching. See you in the next video.